All right, so in this question, we're going to be asked to find the number of zeros to this quadratic equation. And we're being asked to do this using the discriminant. Now, what is the discriminant? Well, the discriminant is this. It's b squared minus 4ac. Call that d for discriminant. And the way it works is if you calculate this and it's greater than 0, this means you have two solutions for where this whole equation touches 0 on the x-axis. If you do this and it comes out to be 0, then you have one solution for where this equation touches the x-axis. And finally, if you do this and it comes out to be less than 0 or negative, then you have no solutions. In other words, the graph never touches the x-axis. So let's go ahead and use this and find the discriminant of this equation. First of all, the a here is 1, the b is 6, and the c is 9. And I'm just going off of ax squared plus bx plus c. And so if I use these with the discriminant, I'm going to have 6 squared minus 4 times 1 times 9. That gives me 36. And then 4 times 1 times 9, that's also 36. And 36 minus 36, that comes out to be 0. So because the discriminant equals 0, that means we have one solution for this equation where it equals 0 on the x-axis. Now, that's all the question asked us to do. But for reference, I'm going to go ahead and factor this and then use the factored form to graph it. Factoring this is really straightforward because I just have x squared plus 6x plus 9. And so I need two things that multiply to give me 9 and add up to give me 6. Well, that's just going to be plus 3 and plus 3. 3 times 3 is 9, 3 plus 3 is 6. Notice I have the same thing twice, so I can just write that as x plus 3 all squared. And so the thing that makes this equal 0 is when x equals negative 3. Notice if I put negative 3 in for x, I'd have negative 3 plus 3, which is 0, and 0 squared is 0. So if I graph this, then the only place where this touches the x-axis or equals 0 is over here at negative 3. And then because the number in front of the x squared here is positive, I know that this is a parabola going up like this. So if that's the only place I touch 0, everywhere else must curve up and away from that. So there we go. If we're using the discriminant to determine the number of solutions, we're simply plugging into b squared minus 4ac, and then remembering what it means when we have these different values for the discriminant. And then for reference, we went ahead and factored it and used the factored form to graph, and we see that indeed it has one place where it touches the x-axis. And that is this example.